Another practical application in the lab is in selective precipitation. Again, you'll notice these are all about controlling your reactions. That's the reason why we're interested in studying equilibrium. We want to be able to control reactions. We want to be able to have some reactions go and have some reactions not go, right? So let's say your solution is buffered at pH of 9. So you can make a buffer. So you have a reaction mixture, you buffer it to pH of 9. What would be a good buffer for that we've seen earlier? You remember? pKa of ammonium was like 9.26. So an ammonium chloride buffer would be something you might want to use for that. Okay, so your pH of your solution is buffered at 9. Which cation, if present at a concentration of 0.01, will not precipitate? So let's say you have a mixture that has calcium ions and aluminum ions, and the concentration of either one is 0.01 molar. Okay? Let's say you want to separate the two. Can't you separate them by precipitating one but not the other? You can try precipitating one of these two but not the other. You can calculate that if that would happen at a pH of 9. So how do we do that? Well, what's the concentration of hydroxide H plus at pH 9? Let's do hydroxide since we're doing the hydroxides. Okay. So what's POH at 9? pH of 9. If I know my pH, what's my POH? 14 minus pH, right? So 14.000 minus 9.00. That gives me a POH of 5.00, right? So if my POH is 5, what's my hydroxide concentration? It's going to be 1.0 times 10 to the negative 5. Okay, let's review. How do we know if we're going to get a precipitate or not? We calculate the ion product and compare it to KSP, right? So what's Q for calcium hydroxide? So it's going to be calcium ions times hydroxide squared, right? So what's our calcium ion here? We're going to say it's 0.01, and our hydroxide is 1.0 times 10 to the negative 5th. Square that. So that gives you how much? This is 10 to the negative 10, and that's 10 to the negative 2, so that's 1.0 times 10 to the negative 12. How does that compare to KSP? What's the KSP of calcium hydroxide? 5 times 10 to the negative 6. Okay, so that's less than 5 times 10 to the negative 6. It's less than the KSP. So calcium hydroxide will not precipitate. You can do a similar calculation for aluminum hydroxide. And let's see if it will precipitate. So Q, the ion product for aluminum hydroxide, equals aluminum concentration times hydroxide concentration, but this time it's going to be cubed, right? Because you have 3 ions of hydroxide in your aluminum hydroxide. So again, aluminum concentration is 0.01, same as the calcium, and hydroxide is 1.0 times 10 to the negative 5, so you cube that, and what would that give you? That's 10 to the negative 15, and this is 10 to the negative 2, so that's 1.0 times 10 to the negative 17. How does that compare to the KSP of aluminum hydroxide? KSP of aluminum hydroxide is 3 times 10 to the negative 34. So compare that. Is that bigger or smaller? Much bigger, right? So it's much larger than the KSP, so this will precipitate. Q is greater than KSP. So that's another application in the lab of the idea of equilibrium.